Hi, fifth graders. So today we're just going to do a very short review of chapter 1 and 2 of ecosystem restoration. And then I wanted to talk to you guys about making a model of what you guys have learned so far and your ideas about why the jaguars and sloths aren't growing and thriving in the project area and why the Cecropia trees aren't growing and thriving in the project area. And thinking about the big question we have for the whole unit, how do organisms in an ecosystem get matter and energy that they need to grow and thrive? So we're going to go all the way back to chapter 1 and review chapter 1 also, okay? So what I'm going to do is, always fun with Mrs. Landscholes. Okay, so we're going to look here first at our vocabulary. So we've talked about ecologist being a scientist who studies ecosystems. All living things and non-living things in an area is an environment. Molecules are groups of atoms joined together in a particular way. Matter is the stuff things are made of. We've been synthesizing or putting together multiple pieces of information in order to understand something. We have been using models, and we are going to make a model today, and that's something that scientists make in order to answer a question about the real world. We've also been looking at arguments, so the use of evidence to say why one idea is the best. And we've been looking at claims, which is a proposed answer to a question, and how any claim should be backed up with evidence or information that supports an answer to a question. We've been observing using our 5 senses to gather information. We've talked about food webs. A food web is a diagram that shows what eats what in an ecosystem. And then we've been looking at some data, some observations and measurements that are recorded in an investigation. We made a restoration plan. Restoration is the process of returning something to its original condition by fixing it. And then 2 of our new vocabulary words are organism, which is a living thing such as a plant or animal, and energy, the ability to make things move or change. So let me move my chair here. In the first chapter, our whole unit's question is, how do organisms in an ecosystem get the matter and energy they need to grow and thrive? And the first chapter focused on why aren't the jaguars and sloths growing and thriving? So we saw, especially through the sim, that the jaguars and sloths were just not growing and thriving in that project area. We learned that everything is made of matter, and matter is made of molecules. We learned that animals grow by changing food molecules into body molecules that can build their bodies. And we also learned that animals use some food molecules to release energy for movement and growth, and that food molecules in an ecosystem can always be traced back to plants. Then we decided that there are not enough plants in the project area, and that's why the sloths and jaguars were not growing and thriving, because jaguars eat the sloths and sloths eat the Cecropia trees. And since there were fewer Cecropia trees, that meant that there were fewer sloths, and then that meant that there were fewer jaguars. So we know that food molecules turn into body molecules. So if there's not enough Cecropia trees, then the sloths can't grow and thrive. And then if the sloths can't grow and thrive, then the jaguars can't grow and thrive because the jaguars eat the sloths. All right, so then we made a restoration plan to plant more plants and then collect more data. So that's where we're at now with chapter 2. We just finished chapter 2, and chapter 2's question is, why aren't the Cecropia trees growing and thriving? And you could see that my daughter Morgan drew a little heart there. Not sure why. Okay, moving on. So the first thing that we learned was that plants use water molecules carbon dioxide molecules from the air and energy from the sun to make food. We talked about this being photosynthesis. So water, carbon dioxide, energy from the sun. Those were three of our claims as to why the Cecropia trees are not growing and thriving. We also learned that animals and plants grow by changing food molecules into body molecules that can build their bodies. So just like we learned in the first chapter. But we know that it's not just animals that grow that way, it's plants that grow that way too. Then we learned that animals and plants use some food molecules to release energy for movement and growth. So just like the first chapter, when we learned that animals do that, we know plants do that too. We also know that energy in an ecosystem, it's not just that food molecules can be traced back to plants, it's that all energy in an ecosystem can always be traced back to the sun. Okay, the sun is needed for all of that energy in the ecosystem. And then at the end of the chapter, we learned that scientists convince others that their claims are correct by using data and ideas as evidence. So now we're wondering why? Why aren't the Cecropia trees growing and thriving? What's going on with them? So what you're going to be doing today, let me just switch this around to me. Hi. What you're going to be doing today is making a model. So I attached to the assignment a sheet for you to make a model. And on this sheet, looks like this. First, it has our chapter question at the top. Our chapter question is, how do organisms in an unit question. How do organisms in an ecosystem get the matter and energy they need to grow and thrive? And the two chapter questions we've had so far are, why aren't the jaguars and sloths growing and thriving? And we just reviewed why that's happening. There's not enough Cecropia trees. There's not enough plants. And then, why aren't the Cecropia trees growing and thriving? That's something that we haven't completely investigated. In the last lesson that you guys did, you listed some ideas of why you think that's happening. You made some claims. So here I want you to do some drawing and draw what's happening in the project area where we know that the Cecropia trees aren't growing and thriving and the jaguars and sloths aren't growing and thriving. And then what's happening in the healthy rainforest where those things are thriving, where all of those things are thriving and everything is in balance. And then you've got a big list of words that you could use. You don't have to use all these words in your model, but these are some words that you can use, and it kind of helps you to think about what you want to draw. Okay, remember that models they can have drawings, labels, arrows to show movement or the direction of something. You can do zoom-ins, you can do cutaways, diagrams. You could put questions on there. You could put explanations on there. So if you can print this out and do it right on this paper, that's awesome. If you can't, then you can always just do it on a regular piece of paper and just put project area on one side and healthy rainforest on the other side, and then you're good to go. And then just look at this from your computer. What I'd like you to do with it is I'm going to put a Flipgrid up, and I would love for you to explain your picture just by holding it up and explaining it like this on a Flipgrid. If that is not possible for you, if it's being wonky or whatever, then you can just take a photograph of it and you can either upload it to the assignment or you can send it to me. But I really want to see your models because this is the biggest thing that I miss about not teaching science in person with you, is that I really like seeing your models and talking to you guys about your models and your ideas, and it's really hard to do that when we're online. So I would love, love, love to see some of these models and to be able to talk about them with you guys because your ideas are fascinating to me, okay? So we are almost done with ecosystem restoration. We've only got a few more lessons left in chapter 3. And I am really looking forward to seeing your models and talking about them with you guys. Okay, I miss everybody, and I wish I could teach science to you for real, face to face. And I hope you guys are all well. Okay, bye.